recording again. Okay, back to that. Okay, so just our arc and sectors again, our equations. Okay, just a wee reminder of what that is. We've got our full circle. Thanks, Ali. We've got our full circle. Okay, so you'll get given either a full circle with a segment cut out like that, okay, or you'll get given like a pizza slice sort of shape, okay, and you need to be aware of we're looking at an arc or sector type question. So I'll show you that in the past papers and just how to pick them up, okay. It is quite obvious, okay, especially they actually ask for arc or sector, okay. But when we're looking at the full circle, remember we've got the arc will be in the outside, okay, so that's why we use the circumference. So the outside of the circle, the full way round, is called the circumference. Okay, if we take a wee sector of that, so say that shape there, okay, just the outside shape of it, okay, the outside line, the outside surface, that's going to be the minor arc, okay, and then all the way around the rest of it, that's going to be the major arc, okay, major and minor. Now they'll ask for the major or minor in the question, okay, or sometimes we'll ask for the major or minor in the question, okay. They might word that a wee bit more awkwardly. So when they're talking about arc, they're talking about a portion of the circumference, a portion of that outside edge of the circle, okay. Minor's the smaller one, major's the bigger one. When they're talking about sectors, they're talking about areas. So that's why it's sector over the area, so sector over pi r squared. Now, along the same lines as the arcs, that area inside there, draw it. That area in there would be the minor sector. And probably guessed it, the rest of that area, okay, would be the major sector. Okay, so no surprises there. Okay, but just be aware of what they're asking for. Don't work out the wrong sector or the wrong arc. Okay, be silly. Okay, so let's have a wee look. We did a few examples of that in the class. So I'll have a wee look at some exam papers. Past paper questions. We'll go through them. Okay, what we got there? What was the one I was looking at? This one. Okay, so as I said, don't try and draw this out if you've not got a compass and stuff, and don't take too long. Just write down this bit, okay? Just write down 2018 paper 2 question 2, okay? So past paper 2018 paper 2 question 2, okay? When you go through and when you look through your notes, then that will tell you to refer back to that and it will make more sense. So don't try and draw this out, we'll just go through it. Okay, so that if we snip that. Oh, what did I do last time? 2 seconds, guys. So when you don't do it every day online, forget what you're doing. It's not what I wanted. Okay, let's have a look at this. So the ones from last week. Okay, again, so I'll send this out, guys, don't worry about this. Okay, so nice, quite a nice question, this. Okay, it's probably the best way they can ask it, okay, because it's asking it in a way that we want. Okay, so it's asking for the major arc. All the bits of information are really quite obvious. Okay, so there's nothing to sort of shock you. You're given the right angle, you're given the radius there, and they're asking for the major arc. Okay, so I'm going to write it out the way I prefer, if that behaves itself. Okay, so angle over 360, okay, so that's the given angle, equals arc over the circumference. Okay, now in the exam you probably wouldn't want to write that out fully. Okay, so if you just write the angle, or if you use the symbol we've been using for angle the whole way through, okay, that symbol there is just theta, okay, and in mathematical terms that means angle. Okay, so if you see that wee symbol, that's what it is. So angle equals over 360 equals the arc, the length of the arc, and the circumference is pi times diameter. Okay. So the angle that we're given is the 320. Now, they're looking for the major arcs. They're looking for that outside edge, the big outside edge. So they're looking for A all the way around to B. Okay. Sometimes they might try and throw you and say, and give you that type of information, but ask for the minor arc. The minor arc would be the smaller one. Okay, so just bear that in mind, just look out for that. Okay, so the major arc, that's the angle we've been given. Okay, so 320 over 360 equals arc over pi times the diameter. Now they give us the radius, okay, diameter just equals 2 times the radius. Okay, so the radius is half the diameter, or the diameter is 2 times radius. Okay, so 2 times 7.4 equals 14.8. Okay, so that's the diameter I'm using in there. You can just do that to one side or in line, just nice and neat for you. Okay, I say that when I'm doing it really untidy. So that would be my equation. Okay, now my unknown in this is that arc. Okay, so do a couple of things. We can keep that on the right hand side, or when we were rearranging equations, we liked the fact when the unknown was on the left hand side. Now remember that equal signs means I can just spin that equation round and it doesn't change anything. Okay, so that line is the exact same as, and the only reason I do that is so my unknown's on the side I want it to be. Okay, remember we want our unknown on the top of any fraction on the left hand side. Okay, and we want to end up with it on the left hand side. So now when I rearrange that equation, okay, my unknown is where I am. And that's just a neatness thing. You can leave it like this. It's not a problem in the exam, okay, but your unknown's just going to be on the right hand side. Okay, so it'll be something equals arc, exact same. Okay, so don't worry too much about that, but remember with that equal sign, we can just flip it round. Okay, so want to leave arc on its own, 320 over 360, and oh, a different colour. Want to take all that and move it over here. Okay, want to take all that in the bottom and move it over. Okay, so both of these things on the left hand side, we're dividing the arc by it. Okay, so when we move it over to the right, they both become multiplied. Okay, so don't be thrown the fact that it says pi times 14.8. Okay, they're both underneath that word arc. Okay, so they're both underneath that length that we're finding. So when we move them over, it's that fraction 320 over 360 multiplied by pi multiplied by 14.8. If you put that in your calculator, you should be getting 41.3 centimeters out. Okay. It's nice when it says the internet is unstable. If I drop in and out, guys, if I miss anything, if I stutter at any point, it's because my internet, okay? Trust me. All right, so if you miss anything, just flag that up to me and I'll go over it again, okay? So they're quite nice questions. That's probably the nicest way they can ask you. Okay, I think, Carly, I think you just came in. We're just going over a past paper for arcs and sectors. We covered arcs and sectors a couple of weeks ago in class. So just go over a past paper. So instead of trying to draw that out, if you just write 2018 paper 2 question 2, and I'll send you a list of these questions, and if it's in your notes you can just refer back. Okay, so instead of trying to draw that out and making a mess, just write 2018 paper 2 question 2. Okay, so that's the way you sort of want it to come up. Okay, that's probably the easiest way they can ask that. Okay, any questions on that? Throw anyone, not follow that, well good. Okay, don't touch that, don't touch that yet. Another way they can ask it, okay, is work out a different part of the unknowns. Okay, so instead of giving you the unknown, which is either the arc, okay, is the unknown, which is the typical way that we teach it first. Okay, they'll ask you what the size of the angle is. Okay, now that's just a different rearranging. It's the exact same equation, okay, but we just need to rearrange it slightly differently. Let me get that one up. Okay, and we'll work through that. So if you want to write down paper 2017, paper 2, question 14, okay, don't try and draw it out. Okay, and then that one. Let me go back to that. Where was I? Okay, so 2017, paper 2, question 14. Paper 2 is a calculator paper, remember? Okay, so when you're doing past paper questions, just be aware of that. Okay, paper 2, calculator paper. What are we looking for? Calculate the size of the reflex angle. Now, that question, the way it's shown, you're obviously working with a sector or an arc. Okay, looking at the data you're given, I'll zoom in a wee bit in case you're watching on your phone. Okay, looking at the data you're given the radius. Okay, so bear in mind, we sometimes use the diameter, or we do use the diameter for arc. Okay, and then it gives you the length of the major arc AB. Again, just even if you sketch or anything on your exam paper, just to make sure. Okay, the major arc's the big one. If they told you the length of the minor arc, you'd have this in here. Okay, so we've got the major arc, we've got the radius, just need to write out that equation. Okay, I'm going to use that symbol, theta symbol, over 360 equals arc over the circumference, so I'm going to write pi d. Okay. Okay, so I won't write it out fully this time. What are we actually trying to find this time? We're trying to find the angle. Okay, so it's actually an easier rearrangement. So, put in our knowns. we get given the arc 31.5, pi is just pi, the diameter is 6.4 times 2, which is 12.8. Okay. If you don't write that out, sorry, someone's just dropping in and out. 2 seconds, not connect. Okay, if you don't write that 6.4 times 2 out in the exam, you won't lose a mark, all right? But it might just be a way to remind you, okay, just write diameter equals 2 times radius. Okay, 2 times radius, 2 times 6.4, diameter equals 12.8 centimeters. Okay, so just write it in the side. It takes 2 seconds to do. Okay, if you do too much in your head during the exam, you sometimes miss a wee step. All right, so just make sure. Okay, 31.5 divided by pi over 12.8. Okay, just be careful when we're putting this in a calculator. So let's rearrange this first. That 360 comes across. Okay, then we're putting this in our calculator. Oops. 31.5. Oops. No. 282. Sweet. Perfect. Okay, so 282 degrees. Okay, and remember your units. Move that out and write it out a wee bit better. Okay, that wee circle I put means degrees. Okay, so 282 degrees. Okay, so that's the angle. So actually quite a nice question. Okay, is anyone putting that in their calculator and not getting that out? If you aren't getting that out, and I think this came up in the class, if you put that bottom line, the pi times 12.8, if you put that in brackets, so in my case it's 31.5 divided by, and then in brackets, pi times 12.8, and then out with fraction, put times 360, okay? It might just be the order you're putting it in your calculator, okay? So make sure you're comfortable with putting that in your calculator to get 282 out. Nice one. Any questions? We good? No, just having a wee look there. Okay, so let's have a wee look. Leave that to later. Okay, I wanted to look at this one. This one here. Because there's quite a lot going on in this one, so let's have a wee look. Okay, so don't try and draw it out. If you write specimen paper 2, question 11. Okay, so specimen paper 2, question 11. Okay, and then just go through the working. Okay, so let's have a wee look at the question, what it's looking for and what it gives us. It's looking for us, a cone is formed from a paper circle, okay, with a sector removed as shown. Okay, so if you've ever made a cone out of a paper circle, get a wee bit out and then you can fold it up. That's essentially what they're saying there. Okay, it's given us the radius of the paper circle and it's given us angle AOB. It's 110 degrees. Okay, so it shows in the diagram, or it shows in the illustration, what angle they're talking about, and also where the 40 centimeters, the radius. Okay, now it should always do that, make it obvious. Okay, but remember the way they write this. Okay, this angle, the first letter is where you start. The middle letter is an important one. That's where you go to. That's your middle point, where your angle's sort of made up by. And then B is going to be where you finish. Okay, so you follow that path that the letters are set out with. Okay, just like we were doing on Tuesday night. Okay, so just follow that path. AOB is 110 degrees. Tidy that up. Okay, let's have a wee look. Calculate the area of the sector removed from the circle. So that is a wee bit tricky in respect of it shows you a piece of paper, okay, with a bit removed, but the piece of paper is the one that's greyed, it's the big one, okay? That's not what they're asking for. It's asking for the bit that's been removed. It's asking for this wee bit, okay? So it is asking for the minor sector, but it's not said the minor sector, it said the sector removed, okay? I think that could be clearer, but just be aware, okay? So calculate the area of the sector removed. So that's the minor sector that we're looking at. So we're just going through that equation, theta over 360, okay? So the angle that we're given over 360, and it's sector this time, over area, okay? The full area of the circle, okay? So it's the sector, the bit that's cut out, divided by the full area of the circle. Okay, so the angle we're given over 360 equals sector, which we don't know, that's what we're trying to find out, over pi r squared. Okay, importantly, that equation, that pi r squared, you need to know, hopefully you know that already. Okay, pi r squared is the area of a circle. Case of putting in our information, so 110 is the angle we're given. Okay, 360, it's a full circle. Sector is our unknown. Okay, and pi r squared, pi r is 40. Just remember to square that. Okay, going to flip it, spin it round. So sector's on the left hand side, pi times 40 squared. Okay, that means I can move that whole bottom section. Okay, I could move them one at a time and write that out, or I could just move them both at the same time. So it's sector divided by both of those terms. So I'm just taking both of those terms across, multiplied by pi, multiplied by 40 squared. Okay. Area of the sector, therefore, putting that in our calculator. Five three five 1535.8. So 1535.8. At this point, I'm going to check a couple of things. Okay, so I'm going to go back up to the question at this point. I'm going to see if anywhere in the question it asks for significant figures, asks for decimal points, or asks for a format of the way it should be set out. Okay, now in that question it doesn't. Okay, which I'm relatively surprised about. So if you write down the answer 1535.9 or 1535.89, okay, that's correct as well. The answer they've given 1536, they've just rounded up, so there's no decimal points. Okay, so 1535.8, 1535.8, okay, they've left it as 1536. So they've rounded up. Okay, remember your units. An area is going to be something squared. Okay, so centimetres squared in this. Okay, length will just be the unit. Okay, centimetres. An area, centimetres squared. A volume would be centimetres cubed. Okay, just bear that in mind. So that's part A. Nice and easy, hopefully. Okay, let's look at part B. Calculate the circumference of the base of the cone. Now, I think that's not particularly clear, okay? But what they're looking for is the major arc. They're looking for the outside surface A to B. So in part A, we worked out the minor sector. But for part B, they're looking for the major, which is A all the way to B. Okay, that means we need to use the major angle. Okay, the reflex angle. Okay, the big angle. Okay, so we're given that 110. That 110 refers to the minor arc and the minor sector. But if we're asked for the major, then we need to determine that angle there. Okay, we need to determine that angle there. Okay, now, once you determine that, or once you've worked that out, that's what they're looking for, it's not too bad. Okay, so you can write this a couple of different ways. Okay, so part B, your major angle is going to be 360 degrees. Okay, so 360 is your full circle, 360 degrees is a full rotation, minus the 110, it's going to be 250. So 250 is the angle that we use in our equation. Okay, so calculate the circumference of the base of the cone. The base of the cone will be our major arc. Okay, so when we write out our equation, angle over 360 equals arc over circumference, which is pi d. Okay, when we put when we put in our angle, it's 250 over 360 arc over pi times, in the diameter is 2 times the radius, and it's going to be 80. Okay, so there's a couple of things that could catch you out there, okay, or you could misread. That's why you always take it nice and slowly in the exam, read the question fully. Okay, rearrange that, put our variable, our unknown, on the left hand side, so just spin it round. Arc is equal to 250 over 360 multiplied by pi multiplied by 80. Whack that in the calculator, should get 175. Remember that arc is a length from point to point, so the units is just centimetres. Any questions on that one? The way the question was worded, or how we used either of it? Any part of it? Nice one. Looks straightforward. I like that. I'm going to take your word for it, Dylan. I'll never know if you mess that up in the exam, but I'll take your word for it. Right, let's see if there's any other ways that can trick you. Pendulum, okay, that might not jump out you straight away as being a circle, but when I look at it, okay, it gives you the length of the arc. Okay, now it's asking you to calculate the length of the pendulum. It's asking you to calculate this time. essentially the radius of that circle. Again, this comes back to just rearranging that equation. Okay, so the equation that we've been working on, you'll just have to rearrange it. And this time, you'd be working out the diameter and then the radius from there. So work out the diameter and then divide it by 2. Okay, so have a wee go at that one on your own. What else we got? Come back to that one later on because we're going to look at triangles, okay? They sometimes like to double up on different types of questions. So in this type of question, they've doubled up with the sector and they've doubled up with the area of the triangle. So that will be worth quite a lot of marks, I would say. But we'll come back to that one. I'll hopefully finish on that tonight. All right. Even though I don't have a clock. Just jumping out the signal there. I think my internet's been a bit iffy tonight, guys, so if I drop out, let me know. Make sure I'm still recording. Nice one. Ignore that. Okay, this one, I just want to point this out as well. This says paper 1. Now, paper 1 is non-calculator, so the numbers in here you should be able to work with quite easily. Okay, and then it will give you the value for pi. See it down here, 3.14. Okay, now this is why I showed you that document earlier about being able to multiply or divide with a decimal. Okay, so have a wee go at that. So what it wants you to be able to achieve is simplifying a fraction down to its simplest form. So in this case, you'll start with 240 divided by 360, and it will look for you to simplify that right down into its easiest form, okay, the most simplest form. Okay, that's one of these exam skills that we'll work on when we start revision properly. Okay, if you have a wee go at that in your own time, that's not a problem. Okay, but they're sometimes quite tricky. Okay, so have a wee read of that document and then have a wee go at that. Oops. That again is non-calc. I think that's really the only way they can ask you these questions. Okay. So sectors and arcs, nice and easy. Nice and easy. Right, let's have a look at what else we're doing on Tuesday. My God, took me a while. Okay, I want to start with this. So on Tuesday we were working with triangles that weren't right angles. Okay, the week before we were working with triangles with a right angle. Okay, now the reason I want to start with this one when we're looking at triangles is they'll sometimes ask you to prove the Pythagoras, whether it is a right angle or not. Okay, so when we looked at it last week, we looked at that question there. Okay, so if you want to see that, we did it in the video last week. Okay, but I want to look at this one here as well, just the way they've worded it. Okay, so let's start with exactly what I mean. Some people find it confusing when they ask you to prove something about exactly what they're asking. Okay, the fact that they're sometimes asking you to try and get a wrong answer sometimes puts people off. Okay, sometimes the answer will be no. Okay, it is not such and such. So we'll start with a couple of examples. triangles. Something like that. Okay, so go with that. Okay, one side's 3, one side's 4, and that longest side is 5. Okay, it will ask you to, or some along the lines of prove, or is this a right angle triangle? Okay, so is this a right angle triangle, or it will ask you to prove a statement, okay, which is the past paper question we'll look at. Okay, these are actually really quite simple. It's just a case of being able to use that calculation. So remember, when we're looking at right angle triangles, a squared equals b squared plus c squared is the way I wrote that out. Okay, another way of writing that is just the long side squared equals the 2 short sides squared. So we need to prove that that right hand side is equal to that left hand side. Okay, so you can do that by doing it separately, or you could write it out completely as that is. Okay, so you could start by just doing a squared equals 5 squared. Okay, so that left hand side is just going to equal 25. Okay, so the left hand side. The right hand side, okay, is b squared plus c squared. Okay, if we were to write that out fully, 3 squared plus 4 squared. Okay, which is 9 plus 16, which is good. What am I doing? Sorry, ignore that. This is equal to 25. Okay, so the left hand side is equal to the right hand side. Okay, so that's proven. The left hand side is equal to the right hand side. Okay, so the triangle is right angled. Okay, so you're going to need to write out that equation, write out either the left hand side and right hand side, break them up, or keep it together, that's fine. Okay, and go right through it and then write a wee statement at the end. Okay, and it's the wee statement that you get your answer for, the marks for. Okay, let's look at that as part of a past paper question. Diagram below shows the position of 3 towns. Again, don't, in fact, you could draw this out, shouldn't be too hard. The diagram below shows the position of 3 towns. Lowtown is due west of Midtown. Due west just means perfectly horizontal. Okay. The distance from Lowtown to Midtown is shown in the diagram, 75 kilometres. Hightown to Midtown is 110, Hightown to Lowtown is 85. Okay. A lot going on. Nice wee story. Okay. Is Hightown directly north of Lowtown? Okay. A couple things going on. Ask you to know essentially what was east. There you go, there's a brain freeze for you. It asks you to know your sort of compass in this case. Okay. Again, this is one of these things that they assume you know. Okay, so north and east, that would have a right angle. Okay, north and west, again, right angle in there, right angle, right angle. So when it's asking, is Hightown directly north of Lowtown? Okay, it's asking you to know There's going to be a right angle in there. Okay. So that's what it's asking you to do. It's asking you to prove if there's a right angle at low time. Okay. It's asking you to put it into that equation that a squared equals b squared plus c squared. Okay. So a squared equals b squared plus c squared. Okay. So long side squared, you don't need to write this out every time. It's just the short side squared plus the short side squared. Okay, so we need to prove that the left hand side equals the right hand side. So you can do that just by going through, or you can break it up. Okay, so we'll do the left hand side. A squared equals 110 squared, which is equal to 12100. Okay, so a squared, the left hand side of that equation, okay, is equal to 12100. The right hand side of that equation, b squared plus c squared, is equal to 85 squared plus 75 squared, okay, which is equal to 85 squared plus 12850. Okay, so the left hand side doesn't equal the right hand side, therefore it is not a right angle. Okay, it's asking you, is it a right angle? And the answer is no. Okay, so the answer is no. Left hand side does not equal the right hand side. Let me just put that on. Okay. No with valid reason. Okay. So no, the left hand side does not equal the right hand side. Okay. Referring to that equation. Okay. That can sometimes be a wee bit awkward, just the way they ask them. Okay. Just bear that in mind. Pythagoras, that a squared equals b squared plus c squared, only works for right angle triangles. Okay. So right angle triangles. And also the SOHCAHTOA only works in right angle triangles. Okay. So those two things. Where we went on Tuesday was non-right angled. Okay. Where none of the three angles are right angled. Okay. Wee bit trickier to work with. And it comes with a few equations. And remember, these equations will be given to you in the formula sheet, which, if I can zoom out a wee bit, okay. Okay, so in your exam, you're going to get given them. Okay, only thing we need to know is how to work with them and all those letters and how we label up our triangles. Okay, so that is up to us how we label that up. Remember the angle that we pick? That's A. The opposite side will be side A. B. Opposite side, side B. C. Opposite side, side C. Okay, we jumped about that a wee bit. What's the time? 10:07. Pythagoras, Pythagoras, Pythagoras. Okay, so went through a bunch of examples. Never did any past paper, I don't think, on Tuesday. Okay, correct me if I'm wrong. So let's have a wee look at some of the past papers and go from there. Okay, so you can see the two rules up the top. Okay, they're given to you. Calculate the angle of the smallest. Okay, so keep just writing out. So this is paper 2019. Okay, it's paper 2, so it's a calculator paper. It's question 7. Okay. Asking us to calculate the size of the smallest angle in the triangle. Okay. Now, I assume you don't have to work out every angle. Okay. And it's just a visual thing. In that case, I would say that angle. Okay. Angle, what becomes first? X, Z, Y. Okay, is the one we're trying to figure out. Okay. So angle, start at X, go to Z, go to Y. Okay, so it's that angle we're trying to figure out. Now, they don't tell you what rule to use. So we can either pick to use the sine rule or the cosine rule. Now, sine rule, A over sine A equals B over sine B equals C over sine C. Can we use that rule? If we don't know any angles at all in there, could we use that rule to work out? Hell no. Okay, we're going to have at least one other angle that we can determine that to be able to use it. Remember, we only use 2 parts at any one time. Okay, we only know the length of the sides. Thanks, Lynn. We only know the length of the sides. We don't know any other angle, so we can't use 2 parts of that. Okay, we don't know sine A, we don't know sine B, and we don't know sine C. Okay, so we need at least another angle there. So we cannot use that. Okay, oops. Let's go back to our rules. You get given the cos rule written in 2 different ways as well. Okay, remember it gives you a squared equals b squared plus c squared minus 2bc. I'll just take a picture of that actually. Okay, in your exam paper you'll get given it written in two ways. Okay, now how do you pick which one you want to use? Well, both both of these are the exact same equation, just rearranged. Okay, so they've given it to help you out a wee bit, they've just rearranged it for you. Okay, that's why that or's there. So we need to use either the left bit, which is in the red square, or the green square. Okay, now if we're trying to find an angle, then that one there is already set up to find our angle A. So we need to apply this equation to find angle A. So we need to label up our triangle to allow us to find angle A. Okay, so let's go back to that triangle and just label it up. So if we're going to use the equation and we're wanting to find this angle down here, that has to be angle A for us. That means that side, okay, the 6.3 side is side A. Okay, so that's up to us to be able to label that correctly. So we're after angle A. The most important side in this equation then is the side A. Okay, so getting that right. Now, side B and C, when we label that up, it isn't as important. So I can label that B and I can label that C. Okay, I'll show you why that's not as critical later on. Okay, so that's my triangle labelled. You can now go back to using this equation. Okay, write that out. So cos of A equals B squared plus C squared minus A squared over 2BC. Okay, so it's really important we get A correct because that's the one we're taking away. So cos of A is equal to B squared, which we've said is 8.5, plus 7.2 squared minus 6.3 squared, all over 2 times 8.5 times 7.2. Now again, just be careful the way we're putting this into the calculator. Okay, the way I would probably, just for my comfort, just put the top and bottom brackets, top and bottom of this, the calculation in brackets in my calculator. Alright, the calculator should be smart enough to allow you to do it without that. Okay, but I just like to do it just to format it in my head. Alright, so it's for my own sort of benefit. Sticking that into the calculator, 8.5 squared, 6.3 squared, 2 times. We're getting a big long number. Right, so cos A equals, it's a big long one, 0.6895. Right. Now remember, we're looking for just isolate A. We're just looking for that letter A. So we need to move that cos over to the other side. And when you move cos, when you move sine, tan, or cos, it becomes cos to the -1. Okay. Now that's just a button in our calculator. Okay. So shift, then the cos button. Remember, you need a bracket there, so if there's no bracket already, put that there. Okay. Now, I'm getting 46.4. If you're not getting that, give me a wee shout. Okay. I'm just going to quickly go back up to the question just to see if it's asked for any significant figures or decimal points. It's not. So I'm happy with 1 decimal point there. Okay. You could open it out to 2 decimal points if you want, for 1. Okay, but if it doesn't state it, okay, you're not wrong. How do you know? It's up to you to figure out. So how do you know which version? In this case, we're looking for an angle, so the green box makes more sense. All right. If we were looking for a side, then the left-hand side, the red box, would make more sense. Okay, so if it's asking you to work out a side, then you use this equation. If it's asking you to work out an angle, you use this equation. Let's have a look at that then and see if there's any questions that ask for sides, and we'll do the exact same thing. All right, so blah, 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 blah. Calculate the height. Ooh, interesting. There's a bit of Pythagoras in there. Horrible. Calculate the length of DC. The sine. No, it's just about the sine. Calculate sine. Not got that. Try to find one with cos where it's asking you to use a. What's this asking? That's for the angle. AB. There we go. So look at that. Okay, so 2015 paper 2, question 3. Okay. You see that okay? So triangle ABC is shown below. Calculate the length of AB. Okay. Now we're given this time 1 length, 2 lengths, and we're given 1 angle. Okay, so don't know if you can see that when I pull that up, but someone's asking a question about how do you know which angle to use. Okay, in this one. So I labelled, how did I know that's the smallest angle? It was really just through sight. Now, I'd probably say if you've got time and it's not immediately obvious, pick the one that looks the smallest. So in this case, I've picked angle XZY. Okay, work that one out. But if you've got time at the end and you're unsure whether it's that angle or another angle, okay, that they're looking for, work out both. All right. So if you're unsure that that angle there is not the smallest, then at the end of the exam, and you want to double check and you want to confirm that, then do that as the angle. Okay. Now, if that's the angle that you select, that will change the lettering. To work out that angle now becomes A. That means the 7.2 would be side A. Okay, because remember it's always the opposite one. Okay, that means 6.3 could be B and 8.5 would be C. Okay, so if you're asked to find out an angle, that leads you to what is angle A in that equation. Now, you're always given the equation in that format in the exam paper. Okay, so we'll always say cos A equals B squared plus C squared minus A squared over 2BC. Will always be in that. Okay, it won't change the lettering in the formula that you get given in the formula sheet. So it's up to you even though that the letters are X, Y, Z that's used in the question, it's up to you to label the correct angle. Okay, so whatever angle you visually see as being the smallest in this question, which is why I'm not a big fan of the question, it leaves it open to a wee bit of ambiguity. Okay, whatever one you visually see as being the smallest, you label as A, and then the sides you have to correctly label off the back of that. Okay, so if you pick that angle up the top as A, then that means the side down the bottom is going to be A. Okay, but visually, I picked that as A, side A, B and C, I think. Okay, so how do you label it up? In that case, it was just a visual thing. Okay. Okay, so back to this one. 2015, paper 2, question 3. Let's go through it again. What information are you given? You've got side, angle. Okay, now what's it looking for is to calculate? It's looking is to calculate this AB. Okay, the length of this side. Okay, so again, we can quickly look at A over sine A equals B over sine B equals C over sine C. If my internet connection gets a wee bit better. Okay, we can quickly look at that sine one, but we'll quickly see that, again, we're only given one angle, and the angle that we're given doesn't actually help us to work out that missing side. Okay, we need at least two angles there. So again, we're using the cos rule. Okay, again, it comes down to this one. And this time we're looking for a side. Okay, we're looking for that side AB. So it's a case of, are we going to use in the blue box or are we going to use in the red box? This time we're looking for a side. So it's already set up. The blue box is already set up to allow us to find that. That just means that that A side will be this one here, the missing one. Okay, so when we label it up, that side has to be A. That means that angle there, 35 degrees that we're given, that angle is angle A. Okay, and then the rest of it we label up B and C. Okay, so when you're looking for a side, use the equation, use the setup, the format that allows you to work out the side. All right, so A squared equals B squared, which is 1.2 squared plus 1.35 squared minus 2 times, a mouthful, 1.2 times 1.35 times cos of 35. A squared, all that goes into the calculator, 1.2 squared. Yeah, I'm getting 0.61. Am I getting that right? Okay. A equals 0.78. Just double check the units. In this case, it's kilometers. We're working out a length, so it's kilometers, straight up kilometers. Okay, so that's using the cosine rule to work out an angle, and that's using the cosine rule to work out a length. And I think we should have a break. because it's 7:30 and we need to stand up sometimes. Nice one, guys. Let's have a wee look at this one then. Okay, so this is 2016 paper 2 question 8. Okay, so you don't need to sketch it out, we'll just read through it. Okay. See what we've got. Okay, set of step ladders, so a nice wee story for us. Set of step ladders has legs 150 and 140 long. Okay, now they've drawn that out for us in a better illustration. Okay, so we can clearly see it's a triangle. Okay, we can see it's a non-right angle triangle. Okay, and it's given us one of the angles. Now, calculate x, the size of the angle between the shorter leg and the ground. Now, just by looking at it, I'm going to question that result. So let's go through it. Right, so non-right angle, so we're looking at the two rules from the formula sheet. Okay, in fact, I don't know why I'm doing that. Looking at the two formulas. Okay, so we're looking at the formula sheet. We've got those rules, those rules. Okay, so you can even have your formula sheet, rip it off and just have it beside you and just go through what you've got and what you're looking for. So we've got two sides. Okay, so we've got two sides. So I would start with the sine rule just to go through it. Okay, and let's just circle A and B. Okay, and let's just say we've got side A and side B, and we can even start labelling up if you want. Okay, say that's side A and that's side B. Okay, we've not got side C, so we've not got the third side, okay, which would be this side, but might not need it, so let's just keep going. What do we have? We also have the angle here, okay, in this case that will be sine A, okay, and we're looking for this angle here, which on the equation will be B, okay. So just having that beside me, I can circle. So we've got A, we've got B, and we've got one of the angles. So we're missing one of the unknowns, and that's what we're looking for. Okay, in this case, that is the X term I'm looking for. Okay, so I'm going to use the sine rule. Didn't have side C, and I don't need to deal with that. All right, so we're just going to use those two parts. So let's write that out. A over sine A equals B over sine B. Okay. Now we've labelled up the triangle. Okay, so we put in our known. So side A is 140. Angle A is 66. Side B was 150. And angle B is written in the question as an X. Now that's just a letter they've used to find an unknown. So we're finding the unknown X, okay? In this case, it's in our position B. Okay, so don't be thrown by that. Now we want to rearrange this to solve for this unknown. So I'm going to bring this sine X over to the other side. Okay, it's a divide on the right hand side, so it's going to become a multiple on the left hand side. Okay. So the equation becomes that. Now I do that, okay, because I want my unknown on the left-hand side, okay, but I don't just flip that equation around like we did in the previous example, okay, or a couple back when we were looking at sectors, because I want the unknown on the top of any fraction, okay, it makes it easier to work with. Now, if that's in the bottom of a fraction and I took that 150 away from here and took that across down there, that's a perfectly reasonable thing to do, but sin x would still be in the bottom of a fraction, so it's harder to work with. Alright, so you always want your unknown on the top of anything. Okay, so you want it on the left hand side, but you also want it on top. Okay, so it's on the top there. Okay, now I want to isolate that. I want to isolate sin x, so I want to move this across. So divide on the left hand side so it becomes a multiple. At the same time, I'm going to move this 140 across and it's going to become a divide, okay, because it's a multiple on the left hand side. So I'm going to leave myself on the left hand side with sin x. I'm going to have 150, and you don't have to write that multiple sign, but I'll write it just for simplicity, all over 140. Okay. So you can either work that out, put that in your calculator and get an answer for it. 150 sin 66 over 140. Okay, so I'm getting 0.98 out of that. Okay, 0.98. That doesn't tell us anything right now. We want to isolate x on its own. That's what we're trying to find. We're trying to find the angle, okay, that wee x there. So we want to move sin over to the other side. When we move sin from the left to the right, it becomes that sin to the -1. Again, just a button in the calculator, don't worry about it. And then we're putting 0.98 in. Okay, so shift, press sin, then answer equals, and we're getting the answer 78.2 degrees. Alright. Let's go up to it. That makes more sense than 7.8 degrees. Okay, 7.8 degrees is almost flat. Alright, so amazingly, that's given in the past paper, but it's wrong. Right. That's given in the past paper as x equals 78. It should be x equals 78 degrees. Okay, they've added this decimal point incorrectly. Wrong. Which is quite interesting. How is sin 66 calculated in your calculator? That's right here. Oh, what am I on? 8%. This bit's just in your calculator, just sin 66. Just the button sin and then 66. In your calculator, it'll probably show it as brackets there. Okay. And again, in your calculator, if you want to just make it clear in your head, I sometimes put brackets on anything. If I know it's on the top line, I'll just make it tidy in the calculator and put brackets around it. Again, your calculator should be smart enough to know which order to do it in, but it just makes it clearer in my head when I'm putting it into the calculator itself. Alright. Is anyone not seeing that, not getting that? We're good. We're good. We're good. We're good. We're good. I got 78.52. Yeah, so that's fine. That's absolutely fine. The reason it differs is this step here. I put in the full answer in my calculator, and if you rounded it to 0.98 and just put 0.98 in here, it's just a rounding thing. That's absolutely fine. Okay, now there's time in real life where small differences make a big impact, okay, but in certain circumstances, 0.2 of a degree is going to be minimal, okay. In this case, it's a set of ladders, so it's going to be minimal, all right, so don't worry about it. I'll have to look at that on Tuesday, okay, so that 0.9135. Oh, that's a direct message. I'll have a look on Tuesday. All right, nice one. Let's have a wee look. Smallest angle with that. Let's have a wee look at this. Hot air balloon. Right, this is an interesting one because it throws in a couple of different things. All right. Let's take a wee screenshot of that. So, 2019, paper 2, question 19. See, the later it is in the paper, the question, the harder it is. Question 19 will be the last question in this paper. All right. So, there's probably going to be something in there to throw you because I like that. Pain in the arse. Right, let's have a wee look. Let's talk it through. Katie and Mona seem like lovely people. Katie and Mona are looking at a hot air balloon. Blah 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 blah. Represents K and M represents Katie and Mona. All right, that's where they're standing. So the angles they're looking at. The angle 52 degrees and the angle 34 degrees is just the angle which Katie and Mona were looking at the balloon. All right, so that's what that illustration shows. Right, let's have a wee look at what it's asking for. Katie and Mona are 350 metres apart. So we've got one side of a triangle. Okay. Calculate the height of the hot air balloon above the ground. Now, I look at that and visually, could that be a right angle triangle? Visually, not far off. So the first thing I would probably do is just double check that. Okay. Now remember, all the angles in a triangle add up to. All the angles in a triangle add up to 180. Okay. So we can quickly work out angle KBM if my internet allows it. Okay. We can quickly work out angle KBM by doing 180 minus 52 minus 34. Now this is just a wee quick check. I don't actually need this angle, I don't think. Okay, but we'll just have a wee look at it. Okay, so 180 minus 52 minus 34. 180 minus 52 minus 34 would give me an angle of 94 degrees. Okay, so it's pretty close to 90, so I was sort of right to check, all right? But it's not 90, okay? So it's not a right angle. Now, that tells me what rules I'm going to use, okay? If it's not a right angle triangle, and I'm trying to work out some things here, I need to use the sine rule or the cosine rule, okay? The ones in the formula sheet. Not a right angle, okay? Therefore, we're using these. We're using these from the rules from the formula sheet. Okay, so let's have a wee look at what it's looking at. It's a triangle, obviously, blah blah blah. But what they're after is the height from the ground. Now, Katie and Mona are standing on the ground, so that's ground level, okay? At 350, that's ground level, okay? Calculate the height of the hot air balloon above the ground. So they're looking at from B straight down. So what's happening here is we're creating another triangle. So from B, we're going straight down. Now B straight down to the ground level is the height of that balloon. Okay, that's H, the height. Now by doing a line straight down like that, I have now created a right angle. Okay, so I have now created a right angle. Now, right angle triangles, we can use a squared equals b squared plus c squared, or we can use SOHCAHTOA. Okay, now to use either of these, we obviously need some data from that right angle triangle. So if we look at that right angle triangle, what do we actually have? We've got our angle, we've got no sides, so we don't have any information on the sides. Okay, so we either need to work out the length of this side here or this side here, k to b. Now, do we have enough information in that larger triangle, okay, in the full triangle, to allow us to work out the length of KB? Okay, do we have enough information in that large triangle to work out side KB? Okay, so using the rules, so going back to the large triangle, forgetting that right angle triangle for a second. Delete that. Wow, go back. Didn't mean that. That's what I meant. Okay, going back to that larger triangle, is there a way that we can use the rules that we've been working on tonight to work out that side KB? Okay, so let's label a few things up and let's work out a few things. Well, we've got two angles. Okay, so what do we want to mark up here? We worked out the third angle. Let's just put that in, see where it takes us. We worked out that angle is 94. Okay, so we've got that angle plus a side. We want this side, this can be our unknown. We'll put it as x right now, and we've got the opposite angle from that. Right, so we'll put that in red. So we've got angle plus its opposite side, angle, and we're trying to find its opposite side. Okay, so looking at our rules, if we look at the cosine rule right now, if we wanted to find a missing side, so let me zoom in a wee bit. If we wanted to find a missing side, okay, what we would have to have are two additional sides plus one of the angles. Okay, so if we were to find KB, okay, if that was our missing side, KB was our missing side, we'd have to have angle A, which in this case would be 34, which we do have, but we'd also have to have side B and side C. We've got one of the sides, but we've not got the other. So we can't use the cosine rule. Okay, we've not got enough information to use the cosine rule to find that missing side. Okay, so quite a lot going on here. Bear with me. Okay, what we do have is a sine rule. Take this up a wee bit. Okay. Now this time, let's look at what we have. We're missing a side, so we're looking to find a side we'll call A. Okay. Have we got that angle opposite it? Yes. In this case, it's our 34. Okay, in this case it's our 34. So the missing side plus the angle. We've got one of the sides. In this case we've got 350 metres. Okay, we've got that bottom side. Have we got the angle, or can we work out the angle, which we've done? Can we work out the angle opposite that? The answer is yes. Okay, so we can use the sine rule to find an unknown. In this case, it's going to be A. Okay, everyone comfortable with that sort of process? So, go back up here. The sine rule I'm using, side A I've labelled. Okay, that angle is going to be angle A. I'm going to take that 350 metres, that's going to be my side B, and conveniently, this isn't always the case, that's going to be my angle B. Okay, and that's just a coincidence. Okay, so going to use that, this is just the first part of it, alright, to find our missing side. I'm going to substitute those numbers in. Okay, so A over sine A equals B over sine B. Okay, A is our missing side, angle A is sine 34, B was 350, sine of the angle B was 94. Okay, we work that out. We want to isolate A, so we take sine 34, put it up here. Over sine 94. Stick that in my calculator. 350 sine 34. I'm getting a length of 196. I'm going to say 0.2, and that's in meters. Okay, so I'm going to get a length of 196.2 meters. So, what have I just worked out? Go back up there. If I'm zooming in and out, and you're missing something when you're copying, give me a wee shout, okay? What I found out is that in there, so it's 196.2 meters. Okay, so I've now filled in that missing side. Okay, I'm going to tidy up my triangle. Because I'm going to use some of it. Okay, so I've worked out that missing side. So let's go back to what the question's asking. Okay, calculate the height of the hot air balloon above the ground. Okay, so both. Again, we'll go back to what the height. Let's do that. Get a colour. So the height is B. Height of the balloon, the bottom of the balloon, straight down to ground level. Okay, that's good, isn't it? Yeah, trust me. Oh my god, it's not liking me now. Why is it doing that? Don't know why it's doing that now. Okay, but B is, delete that, bottom of the balloon to ground level. Now, if I draw that triangle out so I can work with it a wee bit better. Right, I'll just take this over here since it's not playing ball with me. That's my 196. 196.2. That's the position of my balloon. Okay, that was the position of Katie. The angle in there was 52 degrees, and I'm missing this side here, the height. Okay, so I've pulled that to one side, so that's just the same as the image. Okay, so I can work with it. Now we're working with a right angle triangle. Bringing a line straight down from B down to ground level, it's now created a right angle triangle on the left hand side of that. Okay, so now I've got a right angle triangle with an angle, the hypotenuse. Okay, remember the hypotenuse is always opposite the 90 degree. Okay, and a missing side that we're trying to find out, which is opposite the angle that we get given. So this goes back to when it's a right angle triangle, we can use something called SOHCAHTOA. Okay, what's that coming up? We can use SOHCAHTOA. So sine of the angle equals opposite over hypotenuse, or cos of the angle equals adjacent over hypotenuse, or tan of the angle equals opposite over adjacent. Okay, now what have we got in this calculation? We've got the hypotenuse. That immediately rules out us using tan. Okay, because the tan equation doesn't use a hypotenuse anywhere in it. That's one of the bits of data we've got, so we need to use something, an equation with a hypotenuse in it. We've also got the angle, so again, that helps us with both. But what are we trying to find? What's our missing detail? What's the side opposite the angle? So it's O that we're missing. So sine the angle equals opposite over hypotenuse is the equation we want to use. Okay, so we'll bring that one down. Sine of the angle equals opposite over hypotenuse. We put in what we know. Sine of 52 equals opposite. We don't know what that is, that's our height, over hypotenuse, which we've worked out is 196.2. Okay. Ooh. We want to isolate h. Okay, now this is one of those occasions where I'll just flip that so h is on the left hand side. Okay, so I'm writing out the exact same equation. I've not moved anything yet. I've just put h on the left hand side and writing it out fully again. Okay, that and that is the exact same equation, but I'm just turning it round so h is on the left hand side. Okay, that means I can move this 196 over here. So divide on the left hand side becomes a multiple on the right. Okay. So my height, if I put that in the calculator, 196.2 multiplied by sine 52 is 154.6 in its meters. Okay, so a lot going on. Okay, and it's sometimes not easy to immediately see what you're trying to do. Okay, so it's a case of reading the question once, twice, 3 times, looking at what you've got. It's a triangle, that was pretty obvious. Okay, establish if it's right angle. If it's not right angle, establish what rule you're going to use. Okay, if you can try and make right angle triangles, then do so. Okay, but as I say, that was question 19. Question 19 in a paper 2, in a calculator paper. 19 questions, so that must have been the last question, I'd say. Okay, they make the last question quite tricky to try and throw you, so there's probably a wee bit of work to do. All right. Any questions? Right, what did I want to do? Told you I would finish on a question, didn't I? It wasn't one of them. See this site I'm on? It's a great site. There's so much on it that it's something you're likely to get lost. Okay, so I've given you the link a couple of times, and I'll send it out again. I don't mind sending it out, but if you look at it, it's a huge thing. Okay, just be aware of that. So if you've got any questions, give me a wee shout. Right, I've seen this one, and I want to look at it because it's got a triangle and it's got a arc involved. Christ, 2019 paper was a shocker. This is 2019 as well. (2019) people that made the paper must have been angry. Right, let's have a wee look at this question. Okay, in the diagram below, AOD. Okay, let's have a wee look at that. AOD is that sector there. Okay, AOD is the sector of a circle. Okay, so remember, we need to remember that equation for sector of a circle stuff. And BOC is a triangle. Now it gives you one of the angles, it gives you 75. Okay, now the other two angles, OBC and OCB, are smaller than 75, so I can immediately tell, okay, just visually, that it's not a right angle. Okay, and it's not a right angle. But yeah, that's just a visual thing. Okay, so in sector AOD, you're given the radius of 30 centimeters, and you're given the angle of 75. Okay, so that's an illustration, that's no problem. Okay, in triangle OBC, you're given OB, the side OB is 38, and OC is 55. Okay, so you're given a wee bit of information about the triangle as well. Okay, so looking at the question, calculate the area of the shaded region ABCD. Okay, so the letters ABCD is just the path that marks out the corners of that shape. Okay, so if we go back up to it, a lot of information getting thrown at you. You can also see the shaded area. It's pretty clear what the shaded area is. Just to be really clear, A, B, C, D equals that shape. Okay. Calculate the area of the shaded region below. I'm looking at that triangle. It's not a right angle triangle. Okay. Therefore, I'm thinking area of the triangle, I'm using the sine rule in our formula sheet, which I'll just get. No, I won't. Give me something in my formula sheet. Where's my formula sheet? Formula sheet. Our formula sheet. Okay, so the rule we're using is okay. God. At that point in the night. Is that not letting me go down? Sorry guys. Right, the that we get given, okay, we're looking to find the area of the triangle. To find that shaded grey area in that question, we need to first find the full area of the triangle and then take away the area of the sector. So an area of a triangle, when it's not right angled, you get given the formula in the formula sheet, half AB sine C. Okay, again, we need to label up the triangle correctly to use that formula. Okay, so the first thing we need to do as part of this question is go up to it, and we're going to find the area of the triangle first. Okay, so if we're finding that shaded area, then we want to find the whole area of triangle OBC and then remove the sector from it. Okay, so we just take away the sector. So we're wanting to find the area of the triangle first. We've got an angle, we've got length OB, which is 38, and we've got length OC, which is 55. Okay, to use that equation, we want the angle to be C. Okay, so if we go up to back up to this, okay, that angle there is C. Therefore, that side will be small c, which means the other two sides, the ones we've been given, are going to be side A and side B. Okay, so we can use that equation, which is handy because we've not got any other information. Okay, so let me just cut that. Can I cut that? No. So let's have a wee look. So area equals half AB sine C, half multiplied by A, which I said was 38, multiplied by B, which is 55, multiplied by sine of the angle, which is 75. Okay, so my area of the triangle is half times 38 times 55 times sine of 75. Oops. 1009.4. What are we working with? We're working with centimetres. So the area, remember, is centimetres squared. Okay, so the area of the triangle, 1009.4 centimetres squared. Now, we want this area of the sector as well. Okay, now, that's not immediately obvious, but we're given a radius of 30 centimetres, so that tidy up this again. Let's look what it says and just make sure, okay? In the diagram below, AOD is a sector of a circle, so we can use a sector equation, okay? That means when we're given the radius, 30 centimetres is the distance O to B, or O to D, sorry. So we know that's 30 centimetres. Okay, so we've got the radius of the circle, we've got the angle that we need. Okay, we want to find the area of that sector. So, equation was the angle that we're given over 360 equals sector, okay, so the area of the sector over the area of what that whole circle would have been, which is a calculation pi r squared. Putting in our known values, 75 over 360 equals sector over pi times 30 squared. Can't draw a 3. Okay, I'm going to spin that equation round, so sector's on the left hand side. Pi times 30 squared equals 75 over 360. Okay, I'm going to isolate sector. By moving the bottom over. Okay, so 75 over 360 multiplied by pi multiplied by 30 squared. Okay, so the area of the sector, putting that in my calculator, 75 over 360 multiplied by pi times 30 squared, 589. Point 1. Okay, and again it's an area, we're using centimetres, so 589.1 centimetres squared. Okay, so we've got the area of the full triangle, we've now got the area of the sector, we want the area of that shaded area, which is the triangle minus the sector. Okay, so we take area of shaded area, area of shaded area, I suppose, that's correct. Okay, equals the total area of the triangle, which is 1009.4, minus the area of the sector, which was 589.1. That gives you, in the calculator, 420.3. That would be in centimetres squared. What answer did they give? 420.3. Happy days. Okay, so again, one of those questions with a lot going on. One of those questions which have combined two sections that we've looked at. We've combined areas and sectors, and it's combined triangles, non-right angle triangles. Okay, brought them together and put that question in. Okay, so it's quite tricky. Need to work quite slowly sometimes, but we've got all the knowledge to be able to do it. Cool.